Hey guys, Mr. Jenkins here with the fourth lesson of chapter 3. This is going to be quite a bit tougher than the first three. The first three were kind of the basics, and now we get into applying some of what we did in chapter 2. As you can see, it is called solving multi-step inequalities. We had a lesson in the last chapter that was solving multi-step equations. Lots of similarities here with just new stuff about inequalities thrown in. Your learning target is that you can solve multi-step inequalities. Sounds simple enough, but obviously a lot goes into that. On that note, we'll go ahead and look at a few of them. All right, so looking at example 1a, it says 9 plus 4a is greater than 21. So we want to solve this as if it were an equation. So first step would be move over the plus 9. So we are subtracting 9 from both sides. On the left side, that just gives me 4a. Bring down your inequality symbol. On the right side, it gives me whatever 21 take away 9 is. So as you can see, that's 12. So 4a is greater than 12. And then we're just going to divide both sides by 4. And on the left side, that's going to give me a by itself is greater than whatever 12 divided by 4 is, which is 3. All right, so this is a pretty simple example to start out with. We're not going to worry about graphing and interval notation as much here in this lesson, but I do want to focus on this for these first couple. So how can we check our solution? Well, one thing you got to realize is there are infinitely many solutions with these. There are infinite amount of numbers that are greater than 3. So you're not going to check them all, but you can check numbers that are pretty close to the boundary, okay? So my boundary is 3, and I want any number that is greater than 3 would be a solution. That's what we've just found out, okay? If we sub in 3, what should happen if you solved it right is that we should get 21. Anyways, let's go ahead and sub in 4, okay? 4 should be a solution. So if we say a is 4, then go back to the original. You always go back to the original. That would mean 9 plus 4 times 4 is supposed to be greater than 21, assuming we've done that correctly. So let's see what 9 plus 4 times 4 is. It's going to be 25. So we know 25 is greater than 21. So check it off. That just kind of is a way to confirm your answer is correct. All right, moving on to example B. You know, I look at example B and I know that there's a red flag there. If there is a coefficient that's attached to the variable that's negative, I know I'm going to end up flipping my inequality symbol. Okay, so you've just got to be careful there and know that's coming. Anyways, first thing I want to do is add 7 to both sides. That's going to give me negative 6b is less than or equal to 17 plus 7, or 24. My favorite number, by the way. And then we want to go ahead and divide by negative. I'm going to stop there. As soon as I say divide both sides by negative anything, doesn't matter what, you need to think, oh yeah, I need to flip that inequality symbol or I'll probably forget. Now I'll focus on the computation. Negative 6b over negative 6 is just b. And then 24 over negative 6 is whatever it is. So divided by negative 4. See, that's negative 6. Now I know negative 6 is my boundary number, and that and every number that's greater than that should be solutions. So let's just pick one to test. All right, so I just told you what it means if we plug in our boundary. If we plug in negative 6, I should get 17 on this side, so that doesn't really confirm our answer. Let's plug in a number or substitute a number that is maybe bigger than negative 6. So let's try, negative 5 maybe. So if b is -5, then we have -6 times -5 minus 7 is supposed to be less than or equal to +17. Sorry, I'm realizing that I did this wrong. I have a class full of kids who didn't even tell me that. I think I can cut this out though. So I said divide by -6 on both sides, then I divided by -4. So on the other side, we want 24 divided by -6. So our boundary should be -4. Sorry about that. So anyways, pick a number that's greater than -4. So let's try -3 instead. That should work a little bit better. So if b is -3, going back to the original, that's -6 times -3 minus 7 should be less than or equal to +17. So let's type that in. -6 times -3, and then take away 7, is equal to 11, and then 11 is clearly less than 17, so that makes us feel pretty good about our answer. Okay, let's do one more, and then I'll leave D, E, and F for you to maybe try on your own or check in the notes. They're always a little bit tougher when the variable's on the right side, okay, but same kind of principles apply. All right, so first step is we want to subtract 5 from both sides to move that +5. So -4 minus 5 is going to be -9. So subtracting 5 from both sides gives me -9 is less than 0 minus 3c, so -3c. Let me let that pop up so I write that in the correct spot. All right, then I want to go ahead and divide by negative. As soon as I said negative, my brain's got to think, okay, now I got to flip this. It says less than, let's flip it to greater than. Now we'll worry about the math. So -9 divided by -3 is +3. So we get +3 is greater than C. Now, I would accept this as a correct answer. MathXL might accept this as a correct answer, but it's your job to also know that that means C is less than 3. You need to kind of understand that. Okay, so let's just be a little bit more creative here with how we check our answer. Let's try to sub in. See you guys. Have a nice day. Let's try to sub in a number that's not part of our solution set and see if we get a false. So our solution set is any real number that's less than +3. So let's sub in either 3 or a bigger number. Let's try 4. See you, buddy. So if C equals 4, do we get a false statement? I always go back to the original. Let's see. So that'd be -4 is less than 5 minus 3 times 4. So let's type that in. 5 minus 3 times 4 is -7. So if I bring that down a step, that says -4 is less than -7. -4 is less than -7. Well, that is false because -4 is greater than -7, right? Which that's just a weird way to kind of check your answer, but that would be another way to kind of confirm your answer. If I subbed in numbers like 2 or 1 or 0, those should all give me true statements because our solutions are that C is less than 3 or 3 is greater than C. All right, so like I say, D, E, and F, or I would maybe try those and then check them in the notes. All right, so next we'll get to the word problems and we'll probably wrap up there. 2A says, in a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden, which is 12 foot wide. You have at most 42 feet of fencing. What are the possible lengths of your garden? Okay, so just to kind of diagram this out, what it means, adjacent is kind of a math word. That just means kind of like side by side. You guys got to learn to speak the language, okay? Anyways, if we have two rectangular gardens, kind of side by side, they tell us that our friends is 12 foot. And if they share a side, then that means that ours has to be 12 foot wide, okay? They don't tell us anything about our friend's length. They don't tell us anything about our length, okay? We just need the width for the purposes of this problem, okay? We also need to know the perimeter formula of a rectangle, which we've talked about that some. If I'm talking about fencing in a garden, I need to know its perimeter, right? Because I need fencing to cover that, and that, okay? So prior knowledge, we know perimeter of a rectangle is 2L plus 2W. Now, we're going to try to put all this together now, okay? And I skipped probably the most important part. It wants us to find what are the possible lengths of your garden. So we need to always define our variable. So L is length of garden in feet. Okay, so let's try to figure out what we know and try to put together an inequality here. Okay, so we know that W equals 12 from right there. All right, we also know that we have at most 42 foot of fencing. At most. That's a key word when you're dealing with an inequality. So that means that we could use no more than that. So less than or equal to 42. All right, so when we pull everything together, this is what it looks like. So we would say 42 is greater than or equal to 2L plus 2 times 12, because I subbed in 12 for W. And notice the inequality symbol here says less than or equal to, but here it says greater than or equal to. That's because I put my 42 over on the other side. If the alligator is eating the 42, the alligator needs to keep eating the 42, right? Unless we divide it or multiply by a negative. That's when you would flip it. All right, so I'm going to go ahead and move this term. That's 24. So I'm going to start by doing 42 minus 24, which is 18. So now I'm solving. So I have 18 is greater than or equal to 2L. Go ahead and divide both sides by 2 whenever this pops up, and then we'll finalize our answer. So 9 is greater than or equal to L, or L is less than or equal to 9. All right, so if we think about a graph here, that's any real number less than or equal to 9. So or from negative infinity up to positive 9. Okay, lots of those answers don't make sense in a real world scenario because negatives don't make sense. So we got to cut those out for our official answer, which I'll put over here. So we can say anything, let's say any length or any L greater let's let that pop up, greater than 0 feet and less than or equal to 9 feet. Let's see where we are. Hopefully that shows up right. And less than or equal to 9 feet. All right. So in interval notation, what that would look like is from 0 up to 9, where 0 is not included. Think about why I wouldn't include 0 there in the context of the problem, all the way up to 9, which is included. All right, the last thing I want to do is get you started on B and then let you finish it, and we'll save the last examples for tomorrow. Or not tomorrow, how about Monday? All right, so just putting this one together. Sales associate in a shoe store earns $325 per week plus a commission equal to 4% of her sales. This week, her goal is to earn at least $475, so that's easy at this point, hopefully. We know that that's going to be, or mean, greater than or equal to $475. Hopefully that's easy at this point. At least how many dollars worth of shoes must she sell in order to reach her goal? Okay, so if we're defining our variable, we're looking for some number of sales, so let's let X equal her sales in dollars. Normally I would use S there, but grading your all's last ed puzzle, I had an S on the notes and you guys thought it was a 5, some of you. So anyways, I'm going to stay away from S. All right, so anyways, my expression for total sales is $325 a week is my base. So that's what happens automatically, whether I sell nothing or whether I break the company record, plus 4% of whatever I sell. Remember, 4% means 4 out of 100, right? So 4 out of 100 is just 0.04, right? Some people forget that 4% is actually equal to just 0.04. If you multiply by 4, you found 400%, which that'd be a heck of a commission. So anyways, 325 plus 4% of my sales, which we said is X in the context of this problem, that represents my money I make for however many X I sell, which is sales. All right, and we need that to be at least 475, so greater than or equal to 475. All right, I will let you try to solve from there. That'd be good practice for you. See if your answer makes sense, all that good stuff. But that will be day 1 of 2 on this lesson. We'll get into some real tough ones next time, which would be on Monday. So as always, hopefully this stuff helps. You do not have to finish the whole Math Excel assignment because there will be some tougher ones on there. So you might want to just maybe try to do anything that you're not caught up with. All right, so thanks for your time. You guys have a nice day.